If you're pricing a steel frame project today using last year's assumptions, there's a good chance your budget is already wrong. Imagine signing a fixed price contract in February only to discover a few months later that your structural steel package costs 35% more. That's the reality facing many project teams across the UK right now. On July 1st, 2026, the new UK steel trade measure officially replaced the previous safeguard regime, fundamentally changing how steel enters the UK market. And the consequences are already being felt in project costs, procurement strategies, delivery schedules, and even embodied carbon calculations. Today, we're taking a look at what has changed, why it matters, and what project teams need to do next. Let's start with the policy itself. The government has significantly reduced tariff-free steel import quotas, cutting them by approximately 51% to 60% depending on the product category. Once those quotas are exceeded, imported steel can face tariffs of up to 50%. The stated objective is to protect domestic steel production and strengthen UK manufacturing capacity. The challenge is that domestic production currently supplies only around 30% of UK steel demand. For construction projects, this matters because the additional costs don't simply disappear. They move through merchants, stockholders, fabricators, contractors, and ultimately into project budgets. What begins as a trade policy quickly becomes a commercial issue for everyone involved in delivering buildings and infrastructure. The impact has been dramatic. Structural steel sections have risen from roughly £700 per tonne in February to around £950 per tonne by May 2026. That's an increase of approximately 35% in just a few months. Industry analysts expect UK steel prices to remain up to 25% higher than last year's levels, even after markets stabilise. For project teams, these aren't just numbers on a chart. Higher steel prices can trigger value engineering exercises, reduce contractor margins, create funding gaps, and in some cases, force projects back to the drawing board. The pressure is particularly intense for fabricators and contractors working under fixed price agreements where absorbing these increases can quickly erode profitability. But cost is only part of the story. Steel procurement is becoming less predictable. Global conflicts, geopolitical tensions, shipping disruptions, and supply chain bottlenecks are collectively adding up to 2 weeks to delivery schedules in some cases. That might not sound significant, but on major infrastructure and commercial developments, delays can be extremely expensive. Industry estimates suggest that a single day of delay on a major project can cost anywhere between £1 and £3 million. As a result, procurement teams are ordering earlier, increasing contingency allowances, and spending more time managing supply chain risk than ever before. Lead time certainty is becoming just as valuable as price certainty. Now let's talk about carbon. Many countries have introduced carbon pricing schemes to encourage cleaner manufacturing. The problem is that companies can sometimes avoid those costs simply by importing products from countries with weaker environmental regulations. And that's where CBAM comes in. CBAM, or the Carbon Border Adjustment Mechanism, is designed to level the playing field by ensuring imported goods face a similar carbon cost to domestic products. The European Union CBAM is already operational and is expected to add carbon-related costs of roughly €30 to €35 per tonne for some products. The UK's version of CBAM arrives on January 1st, 2027. For construction professionals, this means carbon performance will increasingly become a procurement issue, not just a sustainability issue. And here's where things get interesting. Many clients assume that buying British automatically means lower embodied carbon. Unfortunately, it's not that simple. At present, the UK has limited capability to produce structural steel using electric arc furnace technology, which generally delivers significantly lower emissions than traditional blast furnace production. Much of today's domestic structural steel production still relies on higher emission processes, while major investments, including Port Talbot's electric arc furnace project, continue toward full operation. This means that the carbon footprint of steel depends on how it was manufactured, not simply where it was manufactured. That's why environmental product declarations, or EPDs, are becoming essential. Two steel beams may provide exactly the same structural performance while having dramatically different embodied carbon footprints. If you want to understand the real environmental impact of your project, you need product-specific EPDs and robust whole-life carbon assessments. So what can project teams actually do? One of the most powerful opportunities is structural steel reuse. Think about it. The cheapest ton of steel is often the one that's already been manufactured. Reusing structural steel reduces demand for virgin material, avoids many of the cost pressures associated with new production, and can significantly reduce embodied carbon. In some cases, it can also help projects avoid exposure to import tariffs and future carbon-related costs The market for reclaimed steel is still developing, but momentum is growing rapidly. Digital material passports, improved traceability systems, and specialist reuse marketplaces are making reclaimed structural steel increasingly viable for commercial projects. And perhaps most importantly, reuse isn't just about materials, it's about designing today's buildings so that tomorrow's projects can recover and reuse those materials. Again, that's the essence of the circular economy. The era of cheap and predictable steel is coming to an end. What we're witnessing is part of a much larger transformation where procurement, resilience, carbon performance, and circular economy thinking are becoming inseparable. Over the next 12 months, every project team should be asking 5 critical questions. Where is our steel coming from? What is its embodied carbon footprint? Could reclaimed steel be used instead? Have we allowed sufficient procurement time? And how will CBAM affect our future costs? The projects that thrive in this new environment won't necessarily be the ones buying the cheapest materials. They'll be the ones making smarter decisions earlier, decisions based on resilience, adaptability, carbon performance, and long-term value. Do you think these reforms will strengthen UK manufacturing, or will they simply make construction more expensive? Let us know your thoughts in the comments below. And if you found this analysis useful, don't forget to like, subscribe, and join us for more insights from the Sustainable Construction Zone.